Welcome to classes on organic chemistry. It is the class solution number 2 on aldehyde and ketones. Today I am going to start the solution of one question of NEET 2022, which was on aldol condensation. I will solve this specially cross aldol. So in my first class on aldehyde and ketones, I explained about aldol condensation, but I skipped cross aldol. So today, before going to the solution of a NEET question, I will first explain cross aldol. What is cross aldol? Actually, aldol condensation occurs aldehyde having alpha hydrogen. I have explained earlier classes, and if the aldol condensation is done between same molecule of aldehyde or same molecule of ketones, then it is simple aldol condensation. Say in short, I am telling you CH3 C double bond say H, and it is same type of aldehyde. Then the technique was, I have shown you the mechanism, and technique was CH3 COH. Am I right? And this attached in this way. This is the way how we will get the answer, aldol condensation. Now today's I will give emphasis on cross aldol, and question was asked on cross aldol. So what is cross aldol? I will take first the example of the question which was asked in the NEET. It was so it is meet with prop propanol and it is meet with prop butanol. So if the two aldehydes are of different type, or two aldehydes are of different ketones are of different types, then these are called cross aldols. But the condition is there should be alpha hydrogen. This is CH3, the carbon attached to CH, if it has hydrogen, that is alpha hydrogen. That is the essential criteria for cross or simple aldol condensation. Now in the question it was asked propanol and butanol, if they are made to, if they undergo aldol condensation, cross aldol condensation, which one of the following product is not the answer? It is a bit hard. The question is a bit hard. So first of all, let us explain how we get cross aldol, how we get the product of cross aldol. Cross aldol product is not easy, and simply you can't do it. You assume first one as A and second one B, and you write the product A plus A as number 1 product, A plus B product number 2, B plus A product number 3, and B plus B is product number 4. So you minutely follow, you can understand very easily. There will be 4 products. We will get 4 products. We will in a very speedy manner we will write the answer, and it is actually one of the solution of your chapter exercise 12.9, page number 386. You are asked to write the product of these two one and also name the product, and also you are asked to mention which one is electrophile and which one is nucleophile. So minutely follow, I will show one by one. So say this is A, we are taking the example AA, am I right? So CH3 CH 2 C double bond OH. AM is of same type. So how you write the next one? Next one is you write CH3 CH2 C double bond you write in this way. This is alpha, am I right? This is alpha. So here you write carbon, hydrogen, one hydrogen above, CH2 CHH, am I right? And put CH3 below. This part is over, you write this part, am I right? Now this just to see, you write the answer. CH3 CH2 COH CH CH3 CH3, am I right? This is one answer. And probably in the entrance exam one more product, one more step was given. It is very simple. If you use heat, then this hydrogen and this OH will give you lose out, it will go out, am I right? So in these two you will get double bond, CH3 CH2 C double bond C CH3 CH3. So whenever heat is given, then OH and that adjacent H, you remove these two, not water, you remove this one, you will get this one. Sometimes it is given in this form, sometimes it is given in aldol form. Probably I am mistaken. That is CHO. That is CHO, because CH3 CH2 CHO, CH3 CH2 CHO. Am I right? Likewise, this will be CHO, and here this will be CHO. Am I right? So in this way we have got A plus A. Now here this is nucleophile and this is electrophile. Why? Because in the mechanism that hydrogen was abstracted by base. When it is abstracted, this negative part remains on carbon head, and this acts as a nucleophile that attacks on this part. So it is nucleophile because when it is abstracted, one negative part is on carbon, and if bond is withdrawn, this is plus, this is electrophile. So this nucleophile attacks on the electron deficient center. So this is electrophile and this is nucleophile. So this is first one, A plus A. Now what is B plus A? Now what is B plus A? CH3 CH2 CHO CH3 CH2 CH2 CHO. That was B and that was A. Am I right? So let us now write B plus A. Sorry, A plus A plus B. CH3 CH2, this is A, and what is B? This is B. This is B. So here your alpha is this alpha carbon. So that alpha carbon is written in this way. Am I right? That alpha carbon is written in this way, and these two you write in this way, and this will remain in this way. Simple. You add up, you will get CH3 CH2 COH H CH CHO C2H5. On further heating, that H and that H means there will be double bond. I am not showing for time. Now this is electrophile and this is nucleophile, because this hydrogen is being abstracted by OH in the mechanism, that is negative part. That negative part attacks to the electron deficient center. So this is nucleophile and this is electrophile. So next and third one is B plus A. What is B? This is B. CH3, CH2, CH2, C double bond OH. What is A? A is this. So this is alpha. So let us write alpha as in this way. Am I right? And CH3 here. Am I right? CH. If you cannot write properly, you can't get the answer. So you write the answer. CH3, CH2, CH2, COH, H, CH, CH3, CHO. On further heating, that H and OH will remove and there will be double bond. Mind that sometimes it is given. I think it in the entrance double bond in and L part was given. And B plus B you yourself can do now. I am not showing the third one. So this is all about aldol condensation reaction, and that was asked in 2022 NEET exam. Am I right? So another one is Cannizzaro reaction. Cannizzaro reaction was actually aldehyde having no alpha hydrogen. That was Cannizzaro reaction. I have given that one. Cannizzaro reaction, I shown you the answer as this one. Gave you the one example, that is CHO. There is no alpha hydrogen. Am I right? And that will give one self oxidation reduction, two molecule of the same. One is concentrated sodium hydroxide. Am I right? So one is reduced part, other is oxidized part. It is self oxidation and reduction. So you know it is maybe COONA or maybe COOH. One is reduced. Reduced means addition of oxygen, hydrogen. One hydrogen here, one hydrogen here, CH2OH. One hydrogen here, one hydrogen here. Two hydrogen is added. Am I right? So it is once reduced and once oxidized. In absence of alpha hydrogen, it is auto or self oxidation and reduction reaction. That is in short the Cannizzaro reaction. Now I am showing you one a bit tough thing, just for aspirant of higher you just see it. It is not tough. Just to follow concentrated sodium hydroxide. Whenever concentrated sodium hydroxide or sodium hydroxide 50%, it is same. The meaning is same. It is Cannizzaro. It is a special type of Cannizzaro which is called intramolecular Cannizzaro. Intramolecular Cannizzaro. That is in the same part there will be oxidation reduction. Just I am doing, it is not tough. You can understand yourself. So you reduce it. You reduce it CH2OH, because there is, I am just showing you this is, am I right? There is one hydrogen, there is one hydrogen. Reduction means addition of two hydrogen, CH2OH. And that part will oxidized, sorry, that part will oxidized means COOH. Again, same thing will happen here. Am I right? So you see here COOH and here CH2OH. It was asked in IIT 2003. IIT question, that was not tough, very simple. Now you see another type of intramolecular of Cannizzaro reactions, sodium hydroxide. Just to see what happens here, that is CH2OH. Am I right? Like above, I have shown you, and that is COOH. Now what if you heat it? One step more in entrance exam it is given. You just remove water. Am I right? Water. What's happened here? Very simple, very simple. CH2 O, C double bond O, O. This is the answer. So these are the some example of intramolecular, within the molecule, intramolecular Cannizzaro reaction. Am I right? So next part, I am coming to again the textual solution for your understanding. 12.13, 12.13, 12.13, page number probably 386 of your textbook. You please open, you can see simple chemical test to distinguish the following. One is propanol, very simple, easily I can do propanol, and other is propanol and propanol. That is here CHO. You need not write the structure, and there is CO. When there is CHO and CO, one thing very simple I am telling you, that aldehyde shows these are oxidized by mild oxidizing agent. One is toluene and phalanx. Toluene silver and phalanx copper. It gives silvery color and it gives with oxygen Cu2O red color. So both these reagents are used for distinction of the two compounds. So toluene and phalanx respond CHO only, but not CO. It is very important thing. Never. So this will respond to toluene to give silvery mixture, and this will not respond. So this is the distinction of these two. Next one is phenol and benzoic acid. Phenol and benzoic acid. Benzoic acid means COOH, and everybody of you know phenol, there is OH. In benzene there is OH. When there is COOH, it will respond to sodium hydrogen carbonate, and it gives brisk effervescence. EFFERVESCENCE. But phenol doesn't. Phenol doesn't react with sodium hydrogen carbonate to give brisk effervescence. Next one is acetophenone and benzophenone. Acetophenone and benzophenone. You need to know something about the structure. What is acetophenone? Acetophenone is very common. Many of you know, I think. This is acetophenone, and benzophenone is benzophenone. This is benzophenone, acetophenone, and this is benzophenone. So here there is CO group, and here this methyl carbonyl, METHYL, methyl carbonyl part. When methyl carbonyl is part is side by side, one is methyl here and carbonyl is after 2 or 3 carbon, it is not so. If methyl carbonyl is side by side, one side, then that compound will obviously show iodoform reaction, because iodoform reactions give you the iodine, it is yellow color. That's why it makes a difference with other one. Am I right? So when that reacts with iodoform, that is iodine or sodium hydroxide or sodium hypoiodite, same thing. Sometimes it is given in your book, sometimes it is given in this way. What it will do? It will a mild oxidizing agent. It oxidized in this way. One part, but we are not concerned with this. We are concerned in that part, not mechanism. That part gives iodoform, CHI3, colored compound. So I have shown you which compound will show iodoform, which in my alcohol chapters. In this chapter also, alcohol also shows, ketones also showed, aldehyde also shows. I have given the differences. Am I right? So you please go through this one. So that one is obviously show iodoform reaction, but this one will not show iodoform reaction. So this is the distinction between acetophenone and benzophenone. Next one is benzoic acid and ethyl benzoate. Benzoic acid, everybody know this is benzoic acid, and ethyl benzoate, it is ester. Am I right? Ethyl benzoate, ethyl benzoate, ethyl benzoate. This is benzoate, O8, ethyl benzoate. Am I right? So again, when carboxylic part is there, sodium hydrogen carbonate, effervescence, effervescence will occur, but no effervescence in ester is seen. So this is another distinguishing test between these two compounds. Next one is acetophenone and benzaldehyde. Acetophenone, and benzaldehyde. Like earlier I have shown you, I will not show it again. It is of the same type. Acetophenone means COCH3 in benzene group. COCH3 means methyl carbonyl part is there, so it will show iodoform, but benzaldehyde will not show iodoform reaction. Next one is pentane 2-one to pentane 3-one. Pentane 2-one to pentane 3-one. 5. It is 3-one and it is 2-one. Am I right? In this way, the structures is like this. Just you see the structure, you can very easily guess what is with which reagent we will distinguish this one. So methyl carbonyl parts side by side, but no methyl carbonyl parts side by side. So it will show iodoform reaction, but it will not show iodoform reaction. So this is the way we can show the distinguish. We can distinguish the two compound with the help of the reagent a beautiful way. Am I right? So next part is again from chapter 12.4. I think it is inside the chapter 370, page number 370. Butanone, propanone, propanel, ethanol. Order of nucleophilic addition. Butanone, propanone, propanel, ethanol. Order of nucleophilic addition. I am not drawing the structure. Butanone. To explain the order of nucleophilic addition, we need to bring 2 points. One is plus I effect and other is steric effect. Steric effect. Because nucleophile will attack more easily if the carbonyl carbon is more electron deficient. More positivity is there. More electron deficient. Am I right? So in terms of plus I effect and steric hindrance, if you see butanol, CH3, CH2, 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 a lots of CH3 is there. There is a lot of steric hindrance. On the other hand, plus I group is there. More the plus I group attached to this one means it is pumping the electron to that, it withdraws the electron. Am I right? So this is negative, this is plus, this is already positive center. Am I right? Electron deficient center. If you now introduce CH3 or alkyl part more and alkyl part more, huge alkyl part, so more will be the pumping, less will be the electron deficiency, and less will be the tendency of nucleophile to attack. So due to steric hindrance, this has got least effect. So here 3 carbon CH3 CH3 CH3, am I right? So again bulkiness is a bit less, but here propanol CH3 CH2 C double bond O, am I right? So now it is not butane, not propane, steric index is less, and less the steric index, less also minus I effect. So less is the satisfying tendency of positivity of carbon. So with response in comparison of these two, it is more reactive towards nucleophilic addition. Now ethanol again it is less, CH3 CHO, am I right? CH3 CHO. So here you are getting plus I effect in this, steric index is less, so it is. So if you draw the order of the nucleophilic addition will be like this. So in short this is so. Now acetophenone para tolualdehyde, acetophenone para tolualdehyde, comma benzaldehyde, comma para nitro benzaldehyde. This is this one, acetophenone. So again nucleophilic addition, nucleophile maybe HCN or maybe anything, nucleophilic addition order of, you are asked to arrange in increasing or decreasing order of nucleophilic addition. Acetophenone, you have no two benzene CO CH3 group is there. Again there is steric and plus I effect. Paratoluendehyde, if you draw the structure, then you can understand very easily. I am showing you this structure, you see, am I right? When minus I group is attached with either in the chain aliphatic compound or in aromatic compound, more is the electron deficiency in CO center, more will the chances of nucleophile to attack in this center. So in this respect I think it is the highest, because in other cases there is no minus I effect, it is plus I effect. So here it is directly attached to this one, so this positivity will be satisfied in a larger extent. So less the positivity on carbon, less is the tendency of nucleophile to attack. So between these two it is, am I right? Here no plus I group is there, this is this. So the order of nucleophilic addition is like this. You are asked boiling point, arrange increasing order of boiling point. You see highest hydrogen bonding is there, then next, then again less, then least. So blindly you write in this way. This is mapping, and it requires a lot of thinking, and whenever you can understand what are the things, what are the roads given, very easily you can answer instantly without thinking much. If your thinking is to the point, you can just skip to one question here. Ditertiary butyl ketone, ditertiary butyl ketone, and you are asked to nucleophilic addition of HCl. Where HCl is there, nucleophile is Cl. So this is the structure. So what is, to explain the structures, let us first draw the structure. This is third butyl part, am I right? You draw the how to write the structure, you see, am I right? So in between a carbonyl part is there. So that is third butyl ketone, and other is methyl third butyl ketone. So this is third butyl part, this is methyl, this is ketone. In terms of bulkiness, it is in second position, it is in third position, it is huge bulky position. Bulkiness is a bit less, and it is the least. So the order will be like this. Or in terms of say I group, if you want to tell, So here in Balkanese there is also more is I group. More is the I group, less is the positivity, less is the tendency of methyl nucleophile CN to attack. So it is the order of HCN in this point 7. Again maybe page number 386. The questions are you are asked which one of the following will undergo Kenizaro and aldol condensation reactions, and also you are asked to name the give the product. For time I will not show you the product, but I will give you which one is first one is methanol CHO. So if you draw this structure, the structure is this, am I right? There is no alpha hydrogen, it will show Kenizaro. I am showing you how to write the answer because one part is this, am I right? So on reduction, what will happen? Two hydrogen will be added, one hydrogen here, other hydrogen here. So you are getting 1, 2, 3 and other is 1, 2 and other is 3, CH3 and 1 H is there, methanol. And reduction, CHO group will become COOH. Am I right? So these are the product you yourself can write. Am I right? So formaldehyde will show Kenizaro reaction. Why? The reason is that very simple. It has no alpha hydrogen. This is benzaldehyde. Benzaldehyde. There is no alpha hydrogen. This is Kenizaro. This will show Kenizaro. Sodium hydroxide concentrated. Am I right? So one is CH2OH. I am not interested to write the answer. You yourself can do this one, I think. One is reduced, other is oxidized. Am I right? So it will show Kenizaro reaction. It will show Kenizaro reaction. Next one is this one, cyclohexanone. And this is alpha. This is also alpha. So there is two hydrogen. Am I right? So when there are two hydrogen, means alpha hydrogen is there. So two molecule of this will combine to give aldol condensation reaction. Aldol condensation reaction with sodium hydroxide base. Am I right? It is dilute or barium hydroxide. So how will you write the answer? Answer is this is OH. Am I right? This is 1, this is 2, this will remain same. How to write? What is the name? Name is 1-hydroxy, and in 1 cyclohexyl, 1-hydroxy, 1 cyclohexyl, cyclohexa. No. So if you ask me how we have got the answer, answer is very simple. You see, there is hydrogen, 2 hydrogen, am I right? 2 hydrogen, and also there are 2 hydrogen. You need not to show this. Anyway, that hydrogen will get attached with this one. This is aldol. So when it is abstracted in mechanism, that alpha hydrogen is abstracted by the base, that will become negative, and that negative part will attack. Here, because the bond will be withdrawn. This is plus carbonyl, this is plus and this is minus. So that nucleophile will attack here. So this bond is through this one. Am I right? So this is the way how we get this result. 1-phenyl propanone, I think 1-phenyl propanone. So CH3 CH2 C double bond O, and this is phenyl. Am I right? 1, 2, 3. So 1-phenyl propanone. I'm sure this is the question. So what will happen? Will it show iodoform? Sorry, aldol or canizaro? Am I right? So naturally, it has got alpha hydrogen. It will show aldol condensation. How will you write the answer? So this is the technique. You see how will you write. So C6H5 C double bond O, and this part here. Am I right? I have written in this style. So same molecule, that alpha hydrogen I will write first. I will write alpha hydrogen first, and this CH3 is here and this is here. So the technique. Am I right? What we get here is C6H5 COH CH2 CH3 CH. I am writing here CH3 C6H5. Nomenclature you yourself can write. Am I right? Write the name. So what is the next one? Next one is butane 1 all. Butane 1 all. So butane 1 all, CH3 CH2 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 OH. Am I right? Butane 1 all. So I think it is OH. Am I right? It will neither show aldol nor show canizaro. Nor show canizaro. So what is the next one? 2 2. So 2 dimethyl butanol. So let us check. Will it show canizaro or aldehyde? You yourself can check it and you yourself can write the answer. See, this is alpha. Am I right? There is no alpha hydrogen, so it will show you canizaro. It will show canizaro was sodium hydroxide concentrated or 50%. 50%. Same thing. So what will be the answer? The answer will be one part is number 1. The whole structure will be the same. This will be reduced. Only in this place you write OH. In carbon 1 hydrogen and in oxygen 1 hydrogen, CH2OH. Next whole part is same. And second one will be in place of COOH you write COOH. So auto oxidation and reduction. It is canizaro. You yourself name the two compounds. Am I right? And it is very interesting, and very often question asks in entrance, so also in board and all India NCERT questions. Each and every year one question is from remains from this part. From this part. So first of all, you please go through your book 12.6 12.4 page number 370 probably. Inside the chapter you will get this question organic. You just spend some times on reading the question and you will get each and everything in the question. Organic compound A with molecular formula C8 C8 H8O. Before starting this one thing I am telling you, if the carbon number is less than, if the carbon number is less than 6 means 5, number 1. if it is more than 5 and hydrogen is exactly same or one or two more than number of carbon, it is 8, if it is 9, if it is 10, the difference is 1 and 2, mind that it is organic, it is organic compound. And if it is carbon is less than 6 and it is 5 and hydrogen difference is more or less double or a bit more or a bit less of double, that is huge difference of carbon hydrogen, it is aliphatic. One thing, it is not given in the question, I am giving you from my experience. If carbon hydrogen is more than 5 and carbon is more than 5 and carbon hydrogen number is side by side a bit more less, then it is nothing but organic compound, sorry, aromatic compound, and aromatic compound, not organic. And if it is less than 6 and if they or more than 6, mm, uh, more than 6, if the difference of carbon hydrogen is huge, then it is mind that it is aliphatic. So first of all, it is of this compound I am telling it is aromatic because there is huge unsaturation, less hydrogen means less number of hydrogen, it should have been 16 or like that, 16 or like this if it is aliphatic. Less number of hydrogen means a more unsaturation is there, double bonded compounds, double bond is there. Again you come to this one, form an organic red ppt with 2,4 dinitrophenyl hydrogen. 2,4 dinitrophenyl hydrogen, I will draw the structure later on, and it is a compound which reacts with number one point I am showing you. When it reacts with 2,4 dinitrophenyl hydrogen gives yellow ppt means it is either aldehyde or ketone, because 2,4 dinitrophenyl hydrogen reacts with hydrogen means NH2H2 comes and O which O of aldehyde or ketone mix give you water. Am I right? So it is aldehyde or ketone. Now what we infer from other things, yellow PPT on heating with denaturified reagents and gives yellow PPT on heating with iodine. Uh, Iodine and sodium hydroxide means iodoform reaction. Am I right? Iodoform reaction is shown by both aldehyde and ketone, means CH3CO is there. Either other part is maybe H, other part may be another thing. So again it is aldehyde or ketone. Am I right? So next point is it neither reduces tolerance nor failings. This is very important one. It doesn't react with tolerance or failings. So tolerance and failings reacts with CHO compound. So if it doesn't reduce tolerance and failings, that is, it is nothing but ketone. So out of above, we have got aldehyde ketone. And from 3 point, we have cancel out one option. Our option is ketone. Now let's see whether it is aliphatic or aromatic. Again, you are given, you see, it doesn't decolorizes bromine, water, or Bayer's reagent. What is Bayer's reagent? Dilute KMNO4, alkaline KMNO4. Am I right? Direct alkaline. So what's happened? Dilute alkaline KMNO4 in a very fast way. I am telling you. When water is there, it gives glycol. Am I right? It gives glycol. Means decolorizes. It gives a signal of unsaturation, Bayer's. And when bromine is there, also bromine gets added on both sides of double bond. Again, the color of bromine decolorized or fades away. So since this compound, which is assumed to be ketone, does not reduce talents, sorry, doesn't decolorizes bromine water or Bayer's reagent, means it is highly unsaturated compound, double bonded compounds are there, it is aromatic. It is aromatic. So it is aromatic compound. Am I right? It is aromatic ketone. Now let's see how this aromatic ketone uh, and what is its structure. How can we write? The question is CCC8H8. Am I right? So I am rubbing out this part. These parts are for you. Since aromatic is there, so the structure is this aromatic. So aromatic ketone, there is carbon 8, carbon 6 is there. one ketone part is here, 7. So naturally another is carbon, 8. Am I right? So no need to count. It is C8, H8, 11, CH3, CO, CH3. Now what's happened? It forms an orange red color, so 2,4 dinitro phenyl hydrogen, 2,4 dinitro phenyl hydrogen. So better you write double bond here and CH3 here, 2,4 dinitro dinitro phenyl hydrogen. So what's happened here? I am showing you. um 2,4 dinitro phenyl hydrogen. So phenyl hydrogen will be this part, double bond N and this. This is your 2,4 fine dinitro phenyl hydrogen derivative, and its color is this. Next part is on gastric oxidation with chromic acid. Now what's happened? That one H2CrO4. This is chromic acid, na? So that one will become benzoic acid. This is B and this is A. Anything left? And B is this. This is very simple. You just minutely go through the question, automatically you will get the answer. Next one is 12.10. Again page number 86. You please go through the question. An organic compound with molecular formula C9H10, C9H10O. I have told you it is aromatic because the difference is very less and it is more than, carbon number is more than 6. It is aromatic. And let us prove this with the clues which are given in the question. Number 1, 2,4 dinitrophenyl hydrogen when reacts with this compound, reacts with 2,4 dinitrophenyl hydrogen, it gives a phenyl hydrogen derivatives, means it is a carbonyl compound, means aldehyde may be ketone. It is a carbonyl compound. Number 2, reduces tolerance. Number 2, it reduces tolerance and undergo Cannizzaro. So distinctly, toluene is aldehyde gives tolerance reagents and Cannizzaro means CHO is there. So out of carbonyl, maybe CH3 COCH3, maybe CHO is carbonyl, emanate CO group. So it is both aldehyde and ketone. 1,2,4 dinitrophenyl hydrogen and reduces tolerance means CHO, and it is further confirmed it is Cannizzaro, means there is CHO already is there in the compound. And on vigorous oxidation it gives 1,2 benzene dicarboxylic acid. Am I not true that it is aromatic? So from third point we have seen that benzene, it is nothing but aromatic. So we are confirmed. Now let us try to write the structure. Now let's see how we can write the structure. Naturally there will be benzene. Very interesting. These are very interesting. You follow this one. This is benzene. And I have already told there is CHO group. There must be CHO group. There must be CHO group. So how much carbon you have got? There is 6, one is 7. You need another 2. That 2 must be this. It is your structure. So what it is told, 2,4 dinitrophenyl hydrogen. Am I right? So you write yourself. I will not write. You can write the answer. 2,4 phenyl hydrogen is equal to H2 and H2 is hydrogen. One H remove and you write in this way. Phenyl part, and this is nitrogen, and this is nitro 2,4. Am I right? 2,4 phenyl hydrogen. So you remove this one and you get the answer. Am I right? So what's happened on vigorous oxidation? It gives 1 to die. When oxidation on gastric condition, vigorous oxidation is done, so that CO group will become what? COOH dicarboxylic acid. Am I right? On oxidation, alkyl part become COOH. Am I right? So this is the answer. Am I right? Your compound is this. Now Yes, next one is 12 11. Again, it is page number 36. You please promptly go to the question. An organic compound of molecular formula CH816O2. So one clue I have given at the beginning of this one, you see carbon hydrogen huge difference. It is not aromatic, it is aliphatic. Let's see what are the clues are given in the question. My experience shows this. Uh, uh, on hydrolyzed, I have given red line, was hydrolyzed to give carboxylic acid and alcohol. Carboxylic and acid and alcohol is only given is given by esters. Esters on acid hydrolysis gives acid. One is carboxylic acid, another is alcohol. Am I right? So it is nothing but ester. No clues are there. It is ester and it is aliphatic. So what's happened? Um, 1, 2, 3, 4, 5, 6, 7, 8. 8. Am I right? So this is the compound. So which on hydrolysis means acid hydrolyzed or hydrolyzed water molecule is there, H and OH. Just it breaks in this way. Am I right? What we get here is CH3, CH2, CH2, COOH, and another is CH3, CH2, 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 OH. So B and C, that is B, that one is B, and that one is C. Am I right? B and C. C, oxidation of C with chromic acid. Oxidation of chromic acid. Am I right? So this become CH3, CH2, CH2. It is acid. Oxidation of CH2 group becomes CHO. Then further oxidation gives CHO. CH2 becomes CHO and CHO becomes COOH. So is it not B? CH3, CH2, CH2, COOH. And C on dehydration gives but1N. If you dehydrate, means dehydrating reagent is H2 SO4. Am I right? H positive is there. So there is OH here. I'm showing you separately this part. You just see CH3, CH2, 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 here OH. Am I right? And from here you just write 1H here, and on acid hydrolysis these molecules goes out. So what we get here is CH3, CH2, CH double bond, CH2. That is alkene. That is alkene. That is alkene. I have shown it in separate way. So very simple and very easy. Yes. The next and last road mapping is, please go through the question. It is probably 12 into 9 and page number 387 of your textbook. An organic compound contain carbon, carbon, I'm writing first information. Carbon is 69.77% and hydrogen is 11.6%. 63%, and rest is oxygen. And this is, if you subtract from 100, this is this. Am I right? So what the clues are given, it does not reduce tolerance. It reacts with sodium hydrogen carbonate. When reacts with sodium hydrogen carbonate, it is carbonyl compound, maybe ketone, maybe aldehyde. Both ketone and aldehyde, sodium hydrogen bicarbonate reaction is there. First point. Second point, it doesn't reduce tolerance. Means, again, out of these two, does not reduce tolerance means it is ketone. Confirm. And it gives positive iodoform test. Means third point is methyl ketone is side by side. So what about the formula of the structure of the compound? This formula, it is a ketone compound and CH3CO is there. Let us now find out what is the formula. And there is number of moles. If you want to find out number of moles, so you do one thing, 69 by 77 divided by its mass number is 12, and it is 11.63, mass number is 1, and here 18 point. If you do this, you will find answer like this. Am I right? Number of mole and simplest ratio. Simplest, you have done it in first year. Am I right? So divide by lowest result. So this will be 5, this will be 10, and this will be 1. Am I right? So what is empirical formula? Empirical formula is carbon, hydrogen, oxygen. Carbon is how much? 5. Hydrogen is how much? 10. And this is oxygen. So a bit earlier I have shown you, it is nothing but ketone and CH3CO group is side by side. Ketone and CH3CO group is side by side. So what is molecular formula? Molecular formula is equal to N into empirical formula. Am I right? So what is N? N is equal to, you are given molecular formula is mass is 86, and if you calculate 5, 12, it is also 86, so N is 1. So your molecular formula is nothing but 1 into this is equal to C5H10 and O. Let us arrange the structures. Carbon 4, am I right? Carbon 4, CH3CO side by side, because iodoform, COCH3 side by side, and there should be 5, 1. So CH3CO side by side, we have got it from iodoform, and we need 5. Am I right? 1, 2, 3, 4, 5. This is the structure. So these are some extra question, and this is the last part. And first one of the type 2023 NEET question was asked of this type. Say, which one of this compound, say it is A, this is B, this is C, will dehydrated easily. So you know dehydrated reagent is sulfuric acid. So when sulfuric acid, very simple, it is not tough question. Sulfuric acid, and sulfuric acid does what? There is H plus, and there will be protonation. This will come here, and this will become water, and it will go out. So this will become plus. The first one, when H plus comes, that becomes water and go out. So you are getting cation in this position, carbocation. Am I right? In second one, sulfuric acid, when reacts with, again proton comes here, this becomes water and leaves out. Again in this position, you are getting carbocation of this type, there is plus. And here again, if you make the reaction with sulfuric acid, this will become H plus, this is water leaves out, and here you are getting leaves out, this is carbocation. You see, very simple thing, when carbocation is there, you efface it out, there is plus, and it is CO group. CO group is electron withdrawing group, am I right? So it withdraws electron, and that becomes plus. This is plus and this is plus, electron withdrawing, it is withdrawing electron, and this carbocation plus is adjacent to this one, this destabilize the structure, am I right? Again the matter, same matter, it is electron withdrawing part C double O, and again carbocation is here, again this structure is destabilized, where this structure is not destabilized. So ease of dehydration is more in structure C. That question was asked in the type of question of same type, entrance NEET 2023. So now this is from entrance exam. I am showing you very simple question. Maybe simple, you just think, and one hint I will give you, and you will, whenever you will find these things, you will think of Wolf Kishner. So when in my class, just you repeat, you see, when I told about Wolf Krishners and Clemenson, I told you, without knowing anything, you make CO group as CH2 group. Am I right? So you do what? You do what? You do, oh sorry, I think it is Cl. This is Cl and CH3. No matter, you can write here one hydrogen, here one hydrogen, and in next place there will be elimination of this one, and bond will be withdrawn. Only this part is a bit a matter of thinking, otherwise it is very simple, there will be double bond, am I right? So maximum of you can do up to this one, and finally you can't do this one. So it is for you from higher entrance exams, I have chosen this one. And next one from your book again, that was skipped out, and from benzene you are asked to find out, you are asked to prepare benzophenone, and you are asked what is the reagent and what is the starting material. Very simple, just follow, within a fraction of second I will do. You write am I right? Anhydride aluminum chloride, that aluminum will be withdrawn by this one, so you will get this part is electrophile, and this is plus, this will, if it is withdrawn, if it is taken up by AlCl3, so AlCl4, so that part is electrophile, and that electrophile will attack here in the benzene. This is negative, positive part, and benzene will attack, the substitution reaction will occur, am I right? Substitution reaction will occur. So benzene, and this substitution means electrophilic substitution, that electrophile C will attach with the benzene, and that benzene ring is this. So your reagent is anhydride aluminum chloride and benzene COCl3, and this is the last and very interesting. I think you will find the class most interesting and amazing. Please see this one, C6 benzene, that is benzene, that plus CH3COCl, CH3 COCl plus aluminium, aluminium is electron deficient, Lewis acid, are you not getting electrophile? That electrophile would get up COCH3. Better you write in this way, COCH3. Am I right? You are getting A. Am I right? So zinc mercury HCl, is it not Clemenson? That CO group will become like Wolf Kirchner, CH2. See the beauty of the reaction. You are getting this. That on oxidation of KMnO4 in alkaline medium, that alkyl part becomes COOH. So you are getting benzoic acid. Am I right? So what is A? A is CH3 CO. Am I right? That is A. That is A. Now that A is made to react with sodium hypoiodide, means it is iodoform reaction. So when it is made to react with sodium hypoiodide or iodine plus sodium hydroxide, it gives one part, it is oxidizing agent, weak oxidizing agent. Am I right? One part C double bond O Na, and another part is iodoform CHI3. Hope you have enjoyed the class with utmost interest. If you find the class beneficial, please smash the subscribe button and like button.